In a previous video, I showed you how to use get and set to retrieve and change the colors of individual pixels on the screen. In that video, I mentioned that get and set were kind of slow and that there was a faster way. In this video, we'll look at that faster way. I'll tell you right now that if get and set are fast enough for you, for your sketch, then they're often the right way to go. The technique we'll see in this video is faster than using get and set, but it has a few problems. One big problem is it's a little harder to understand and it requires a bit more code. The second problem is if you mess it up, you can actually cause your program to crash. Get and set will never crash. You can even try to get and set pixels that are off screen and everything is fine. Using the technique we'll see here, if you try to retrieve or change a pixel that's not on screen, your program will probably crash and come to a halt. So those are the downsides. The upside is speed. So if you need speed, here's how to go about it. Here's a close-up of a section of the screen that's displaying an image. In this case, it's my New Zealand backpacking photo. The technique that I'll show you in this video is to think of all of the pixels on the screen, every single one of them, as belonging to one giant array of colors. And that array is named pixels with a lowercase p. Now this is not an array that you create. This is an array created for you by processing. So this declaration is for us to remember what the pixels array is. You never need to make this declaration because processing has already done it for you. So let's see how to use the pixels array. The first step is to tell processing to fill it up. When you first run your program, this array, although it exists, doesn't have anything in it. So you need to tell processing, take a snapshot of the current screen and save all of those colors in this array. The way you do that is you call load pixels with a capital P there in the middle. And that takes all the pixels on the screen at that moment and copies them into this array. Now you can do stuff with the array of colors. You read some of them, you write some of them, you change them. Unlike get and set, when you change the values of the pixels array, you're just changing values in the computer memory. To get your new pixels to show, you have to call update pixels, and there's a capital P in the middle. That tells processing, copy all of the contents of the pixels array onto the screen. Of course, after you've called load pixels and before you call update pixels, you're going to change the pixels. So you might read colors out by simply getting the value of pixels sub I. That gives you back the color of the pixel at index I. In a moment, we'll see how to compute I. But for now, just keep in mind that every pixel on the screen is represented somewhere in this array. So I can take out pixel sub I and I get the color of some pixel. Later, of course, I'll probably want to change some of the pixel colors, and that's just as easy. I just assign into pixels sub I, and the pixel at index I will change. When you're all done, you have to call update pixels to copy your pixels back onto the screen. Otherwise, you'll never see your changes. So the only mystery here is, where does I come from? After all, the screen is two-dimensional. Every pixel has an X and a Y. I'll show you how things are organized, and then we'll look at the actual code for computing I. Here's a little visualization of the screen, and I'm using a very tiny little graphics window here. It's only 4 by 4. You can see that I've numbered all of the pixels. At the bottom of the window, I've just lined these 4 rows up, one after the other. Let's see this correspondence graphically. So you can see each of the 4 rows just comes down and goes into the single linear array. Let me do that again. And of course, if we want to think about it in reverse, we can think about elements from the linear array mapping right back up into the graphics window. So this is the general way that we assign numbers to pixels. We start with 0 in the upper left, we work our way to the right, just like reading a book. When we reach the end of the line, we go back to the left, we go down, and we start over again. If we have more elements horizontally, then the same thing happens. Here now, the top row runs from 0 to 7, and then we hit the end of the right-hand edge, we go down to the left, and now we go from 8 to 15, down to the left, 16 to 23. And again, if we wanted to see how these correspond to the linear array, we can just take those 4 rows and move them down. Of course, this still works if we have more rows. Let me take out a few columns just so it's easier to see. And now if I linearize this, we can see them all come down, and if I bring them back up. So this is the general idea. So now let me take out some of the rows and some of the columns, so we're back to our 4x4. Given this setup, we might want to ask what are the x and y values of a pixel given its index number, or vice versa. For example, let's take pixel 9. We can find its x and y values from its row and column. The column is the x value, and the row is the y value. We can find the x value for pixel 9 by looking at the column number at the top, and that's a 1. The y value comes from the row number at the left, and we can see that that's 2. So the pixel at xy values 1, 2 is index 9, and vice versa. This holds for all the pixels. For example, pixel 14 has an x value of 2 and a y value of 3. And the pixel at x value 3, y value 1 has the index 7. To get back and forth from x and y to the index, we just need a little bit of code. So let's take a look at how we go about that. There are only 2 snippets of code that you need to know. One takes x and y and gives you back the index I, and the other goes the other way around. It takes the index I and gives you back x and y. I'll show you both of those snippets now. Let's start with the piece of code that says you have x and y and you want to find I. Here's how you do it. The value is y times width plus x. You'll notice I put y times width in parentheses. I do that just to make it super clear to my eye what's going on. Technically, you don't have to, but I find this is a little bit clearer. Now this is all there is to it. Just take x, y, and the width of the screen and plug them in, and you'll get back the I for that pixel. If you like to play with numbers, then I encourage you to get out a piece of paper and draw some boxes, and you'll figure out why this little snippet of code does the job. If you're not into numbers, don't worry about it. You don't have to know why this works. You just need to know this is what you type to go from x and y to an index I. To go the other way around, we need 2 lines, one to find x and one to find y. And in fact, we find y first. So if we're given the index I and we want to find x and y, here's what we do. First, we find the value for y. What we want to do is to take I divided by the width and take the integer value of that, meaning throwing away the floating point value. To make it really clear that what I want to do is to compute the floating point result and then throw away the fractional part, I multiply I over width by 1.0, forcing the division to be floating point, and then I hand the whole thing to int, which gives me just the integer value. Now that I have y, I get x using this little snippet of code. I compute y times width, and I subtract that from I. As before, if you like playing with these sorts of things, draw some pictures and you'll quickly see why these 2 little bits of code do the job. They go from I to x and y. If you're not into that kind of thing, don't worry about it. This is the code, and you will see these little idioms over and over in people's code. Just about anybody who uses the pixels array to manipulate the color values on the screen will convert from I to x and y and back again using these little snippets of code. These little conversions are so useful, they could have been built right into processing, but they weren't, so we have to type them in ourselves. Let's actually use them. Suppose I want to set the color of every pixel on the screen. Of course, if they're all the same, I could use background. I could even draw one giant rect, but let's do it using pixels, 1 pixel at a time. The general approach is that I'll use 2 loops. Y goes from 0 to height, x goes from 0 to width. So now the innermost line, which is missing at the moment, will refer to every pixel on the screen. So let's set every single pixel to the same color. I'll call it new color. So I want to assign something to pixels sub something. Well, we know exactly what that something is. It's what we saw in the previous slide, the recipe for turning x and y into I. Y times width plus x. That's all there is to it, and this little loop does the same thing as calling background with new color. Let's go the other way and go from I to x and y. If I want to touch every pixel on the screen, I'll write a loop like this. I goes from 0 to width times height. That will touch every single pixel. I have a couple of little stubs here that I'll fill in just a second for computing y and x, and then I assign something to pixels sub I. And because I just want an excuse to use x and y, I'll give it this color, xy, 0. Not very interesting, but at least we see that we can use x and y. So how do we compute y? We use the little recipe from the last slide. We multiply I by 1.0 to make it floating point, divide by width, and then take the integer result of all that. We just throw away the fractional part. To find x, again, we use what we saw in the previous slide. We take I, and from that we subtract the quantity y times width. So that's all you have to do to convert I to x and y, or vice versa. So let's recap. To use the pixels array, you call load pixels, you do stuff to pixels, and then you call update pixels. To get I from x and y, here's the little snippet. And to get the values of x and y from I, here's the corresponding 2-line snippet. So now you know how to talk to pixels in 2 different ways, using getSet and using the pixels array. In the next video, we'll compare these 2 approaches, and that will help us decide which one to use in any given project.